Alright gang, we're working on the chapter 2 review number 49. Now if I do the golden rule and I plug in 2, I'm going to get 0 over 0, so that's indeterminate. So I'm going to use a technique. So the technique I'm going to use is I'm going to factor the numerator. Right, that's a difference of perfect squares. Alright, so let's see, this one's got the minus on the bottom. So what I want to do when I line it up, okay, so hopefully you recognize this from lecture. It's when you have the same thing over the same thing. Right, when you have the same thing over the same thing, it gives you a ratio of 1 or -1, or it's indeterminate right at 2. So you're coming in from 2 from the left. So this one here, right, this one's going to give you a ratio of positive or -1. You have to figure out which it is by coming in from the left. So if you're a little smaller than 2, you're something like 1.9. Okay, something like 1.9. If I put 1.9 into here, it's negative. Because 1.9 minus 2 is negative 0.1. Alright, so this would give me a negative output. But this would always be positive because of the absolute value. So that means if I have a negative over a positive, that's going to give me the -1. Alright, so that's the limit of this guy. Right, I did this one in lecture. That's where you have the 2 straight bars. This one's going to break at 2. So at a quantity of 2, when x is 2, this one, that's where this one gaps between. Oh, hold on a second, I have it going the wrong way. Greater than 2, it's positive 1. Less than 2, it's -1. Right, this is the case we have the gaps. Now this, so the idea is if you have any of the special functions that are very like highly sensitive or particular, you have to handle them very carefully. But anything that's a polynomial, you don't have to hold it with kid gloves. You can just go ahead and plug in. So this part's fine. I can just plug the 2 right into here. 2 plus 2 is 4. So I have a -1 times 4, which overall is -4. So the idea with this is if it's one of those special functions, you got to handle them very carefully. Greatest integer function, absolute value function, right? Some of these functions you have to handle carefully, and I've tried to point them out through lecture. But some of the functions you don't have to handle carefully. Linear functions, polynomial functions, anything that would just do the golden rule, you can just plug that one in. All right, so that's the answer to this. Now, these other 2 here are discontinuities. So you know that if you have a square root function, the radicand, or the thing underneath, has to be greater than or equal to 0. Okay, so this has to be greater than or equal to 0. Now, it just sort of depends. You know, you could factor that from intermediate algebra. You know how to do that. For some people, it's a little easier to see in this format. Okay, but you don't want this thing to go negative. Now, in between these values, I can see that this won't go negative. Like if I plug in anything in this segment, it's going to stay positive. But I think just some people may want to just sort of see this a little better. So this function, it's a cube root function reflected over the x-axis, shifted up 8 units. So let's say this is 8. Right, and it's going to touch the x-axis when x is 2, because it's reflected. Right, so this function looks like, what's sort of fun about being in calculus, well, what is fun about being in calculus is you just have so many techniques and tools now to solve things. Like for some people that are very visual, if I draw something like this, all of a sudden they're going to say, oh, I get it. I get it. To the left, this function's always positive, right, because it's above the x-axis. But to the right, I better cut it off at 2 here, because then it's going to go negative. The heights are going to go negative. So I can just see, looking at this graph, that as long as it's not the left side that's going to end up being the problem, it's the right side, but they cut it at 2. That's where this x-intercept is. This x-intercept is at 2, 0. So this is fine. So this is a continuous function on the segment. If it wasn't on the segment, we'd have a problem. We'd have to eliminate anything greater than 2. All right, but this is a continuous function on the segment. Now this guy, this is just a polynomial. And polynomials are always continuous. They're always continuous. You're not going to have a problem with that. You can use some of your pre-calc techniques if you want, but you really don't need to. I mean, this is a continuous function. It's going up, up on the ends, and then whatever it's going to do, however it's going to turn in the middle, but you're not going to have any holes or gaps in this function. It's got no fractions, it's got no radicals with an even index. This has absolutely no problems. So this is a continuous function. All right, gang, I'll catch you. Bye-bye.